Hey guys, my name is Tom from Filmatra, and welcome to my first actual proper CNC CAD cam, whatever you want to call this video, on this channel. And I'm starting off with a little project idea that I have, and a little project that I'm going to be making very soon, hopefully. And in short, I have the Garant Xtric 80S vise. I have two of them, and they have been absolutely amazing. But their jaws seem to be made to be nearly impossible to machine. They're just a pain. Like, I can machine them, and I've machined some blanks out of aluminum for soft jaws. I've got a couple of them. They're just hard to machine because they've got this dovetail, and then part of the surfaces are machined, part of them are unmachined, or like they are machined, then it's hardened, and then some parts are machined, which like it all starts to be a bit of a pain to make this. Most importantly, make this out of steel. Then the teeth and, you know, the profile, this little cutout, I've got no idea how they do that. I guess they pre-drill it and then take a ball or something. I have no clue, and I don't want to need to know, you know. I don't want to get into making these, but I need to make some jaws because I'm learning, and I've milled off probably up until here of one of the jaws, and another one is pretty beat up as well. And at that point I've got just one vise functional because of that, and the jaws are pretty expensive to buy. And with the amount of mistakes that I do, it would be expensive mistakes, and I don't want to have expensive mistakes, mainly starting a CNC machine shop, because I don't want to have to pour money into, you know, new jaws because I made a single mistake. I want to kind of avoid that if possible. And because I'm not good with steel and I'm an aluminum kind of guy, I came up with an idea on how to make this work without having to mill it all out of steel. So this is my idea. I make this jaw out of aluminum, which I've done before, so I'm perfectly capable of doing that, and I've got basically the the cam ready for that. And just the single change that I do is I make this big hole 20 millimeters wide. I tap, I drill and tap some holes here, and that's basically it. I make that block, and then I make out of C45 steel that's gonna be hardened. I make these little Mighty Bite Talon jaw style inserts that will get put into here. You've got 1.5 millimeter. You're gonna hold their material with the 1.5 millimeter, and basically, really that's it. There's a ton of holes, so there's multiple ways in which you can set this up. You can set it up like that. You can set it up like this for some reason, or like this for whatever reason I might need, or like so, or like this. You know, there's a ton of ways in which this can be set up, and that's why I wanted to make this modular, to be able to not only make these jaws myself, but also make the actual teethed part of it. And I'm gonna show you the cam in a second of how I figured I will make that, but let me show you the CAD of these little teeth. So that's super simple. It's just a 20 by 20 rectangle. It has a hole for an M5, I believe, M5 screw. Yeah, for an M5 screw, and it has little teeth with, this is 1.5 millimeter radius, so 30 millimeter diameter cutouts, and the teeth are 0.2 millimeters high and something like 0.5 millimeters wide. 0.565, and basically that's it. There's this little cutout that's going to be done via two separate passes and two separate operations with a dovetail mill, and it's just going to be done with a chamfer tool, and that is really it. But because if you look at this is precisely aligned by this being 20 millimeters. And because that's going to be 20 millimeters exactly, I need this to also be 20 millimeters, you know, from here to here, it needs to be 20 millimeters. So So how am I gonna do that if I want to harden these? So let me jump into CAM, and let me show you. So operation 1, super simple. Material gets held like this in the serrated jaws and gets adaptive rough. Then it gets faced with the same end mill. I don't have many end mills for steel right now, so I decided this might be the best at the moment. Then I slot it with a 4mm 4 flute, like so. Then I do a contour that leaves 0.3mm stock to leave. I do an inspection probing, so I probe the part and update tool wire. I'm gonna show you how to do that in a second. And then I do the parameters again to get that to as accurate as I can. Then I just drill out the holes with a 5mm drill, and I take the dovetail, and you can see it just just goes in, cuts the cutout. I'm most probably gonna actually do this in a couple of passes so I don't ruin my dovetail mill, because it's an AHS from China, HSS, sorry, from China, so it's not the best. And then I just do a chamfer. So that's operation 1. Operation 2, it gets flipped over like that. Now I'm hoping this will work. I will show you a video when I'm making this, and I'll see if it did work or not, just holding it like that. Hopefully it does. So I just face material, face it again, like so. Super easy. Then I make these bores. And then I take a 3mm 4 flute and I cut the little teeth with it. Now it's going to go at a sharp point. I'm hoping that's not gonna ruin it, but I'm gonna have to try and see. It's not like a very heavy cut, it's a fairly small cut, so I'm hoping that that'll work well. Let me speed it up a little. So that does all the teeth. They're actually final size here, but the sides I still have the stock to leave from the previous op one. So that gets milled. Then I use the dovetail again and finish this part of the teeth. And a little chamfer on top of it to get the top as well. And then you can see there's still material left. So what I'm going to do next is I'm going to quench these, I'm going to harden these. And then I have a little fixture plate, just holes and little corner reliefs, that I'm going to mill exactly to the size of these after they're hardened. And then, super simple, I just run and mill around, cut a little bit off, like so. Then I again probe this, inspect, and wear update tool wear, and then do another finishing pass to get it to size exactly, hopefully. And then I do another probing that's gonna tell me on my machine what size it ended up being. So in case there's any adjustment needed after that, I'm gonna adjust it. But from the very little testing that I've done to this method, it actually does work quite well. And so then I'm still left with some extra stock on the top, but I'm gonna mill that off afterwards. Once I actually put it in the jaws themselves. I'm gonna put it probably one by one or something. I'm just gonna screw them down and mill that off so it's, you know, it can sit next to each other. You can actually see I messed up a little bit on the lead in, lead out. I'm gonna fix that later. Anyways, so I promised to teach you something, not only show off my idea here. So I want to show you how to get the probing to work. So I'm using the Haas official Fusion Autodesk pause processor, and I have this operation, the contour, which I can actually very quickly maybe try to fix the, yes, I actually managed to fix it. And here I set compensation type to where. I press OK, that's OK. Then you do inspection, probing, probe geometry. You select the faces that you want to probe. You've got tolerances here, which, if I remember correctly, it will alarm out if it doesn't. Yeah, you can, if you check here, if it's out of position, then that's where the tolerances are used. But what we are looking for is here in the Actions tab, we do Update Toolbar. We select the operation that milled this. It knows that there's actual stock to leave in it. You can change the error correction percentage in case, you know, if you want to have it like 90%, you can have it 90%. But from what I've tried, 100% worked spot on, like perfectly spot on. So that's been amazing. So that's basically what it does. It just probes that and updates the toolbar, and then you have to do another pass. I'm gonna do that pass that's gonna have 0 stock to leave at this point. Here, compensation set to where. Make sure that's set to where. And basically that is it. That's everything you need. I have another probe geometry that doesn't update any toolbar here. That's just gonna print the results and tell me if it's spot on. If the machine thinks it's spot on, I'm gonna have to measure it with a micrometer, because keep in mind, if the machine is out of tram, or if in any way it's not perfect, you're not gonna find out by probing with a probe in the spindle. You know, if your spindle was slightly offset or something, then you wouldn't know. And yeah, basically that's it. Then I'm gonna show you, probably gonna show you the cam for this part in a later video of this series, because I do not have that set up yet, and I'm gonna probably work on it right now and maybe record a video later today. So yeah, that's everything. I hope this has been helpful to somebody. I might actually end up releasing these files at some point later on, because it could be it could prove useful to somebody who has the same vise and wants to make their own jaws, but is scared of hard milling and combining it in this way. Because this way I have the absolute minimal amount of hard milling to do. I just do the contour and do that accurately, and that's everything. I don't care about any other tolerances really, because the depth and stuff like that, or how the teeth are, like, that's very small stuff, so that's good. Okay, that's everything. Thank you for watching, and if you want to see what else I'm gonna be up to, please subscribe, and yeah, take care. Bye.